Hi, Mac. Here's your video on your questions for lesson 50. So I know you only had 3 questions, so I'm going to make this video and post it to YouTube. But here's your answers to lesson 50. So lesson 50, number 4, it says 3 times Sally's age now exceeds 5 times John's age now by 15. In 10 years, twice Sally's age then will be 20 less than 4 times John's age then. How old will they be in 15 years from now? So what we need to do is we're going to identify Sally and John's current age. So S and J are going to be what I denote their current ages by. Then it says in 10 years. So in 10 years, I would need to add 10 years to their current ages. So these are the variables I'll use for in 10 years. And then our answer will be in 15 years. So after I solve for S and J, I have to add 15 to that to solve. So looking at the first sentence, it says 3 times Sally's age now. So that would be 3S exceeds 5 times John's age by 15. That's my first equation. Then I go to the second equation. It says in 10 years, twice Sally's age. So I'm using these variables here. Twice Sally's age, so 2 times S plus 10 will be 20 less than 4 times John's age then. So 4 times J plus 10. And this is 20 less than that, so minus 20. So now I have 2 equations that contain S and J, and you need to either do substitution or elimination to solve. So what I'm going to do is I'm going to start by distributing the second equation, which would be 2S plus 20 equals 4J plus 40 minus 20. But look at that, 40 minus 20 is actually 20, and there'd be a positive 20 on both sides, so these actually all cancel. And then I can divide both sides by 2 to give me that S is equal to 2J. Now what I want to do is I'm going to take that and I'm going to plug it into this equation here, which would be 3 times 2J equals 5J plus 15. So 3 times 2 is 6J equals 5J plus 15, which means that J is going to be equal to 15. And when I plug that into here, that means S is going to be equal to 30. But remember, they're not asking for their current ages. They're asking for how old they will be in 15 years, which means that John in 15 years will be 30. And then Sally in 15 years will be 45. And that's how you solve number 4. Now moving on to number 5. So number 5 is the big man could do 1/3 of a job in 4 hours. The little man could do half of a job in 2 hours. If the little man needed to complete 30 jobs and worked for 2 hours alone, then was joined by the big man, how long did it take them both to finish the remaining jobs? Okay, so what I need to do first is I have 2 people working together to accomplish one job. So I have RB TB plus RLTL equals jobs. Now, the rate of the big man, instead of using this fraction, it says 1/3 in 4 hours. So if he wanted to finish a whole job, it would take him 12 hours. The rate of the big man would be 1/12. And then it says the little man needed to complete 30 jobs and work for 2 hours alone. So that means the time of the big man is just going to be T. The rate of the little man, half a job in 2 hours, which means a whole job, one job would take him 4 hours. And he is working for the time with the big man plus 2 hours alone. And in total, they're completing 30 jobs. So really it was getting rid of those fractions in the rates to make it a little easier. So to get rid of the fractions, I'm going to multiply everything by 12, which means that this would become 3, it's 1. So I have T plus 3T plus 6 equals 360. Bring the 6 to the other side, would give me 4t is equal to 354. And I think that does divide evenly. Well, not really. So t is going to be equal to 88.5 hours. And you could have left that as a fraction if you wanted to. And that's number 5. Then lastly, we're going to look at number 12. So number 12, I kind of messed up on here, so bear with me. The f function is going to be secant squared, and the g function is going to be cosecant squared. I'm going to rewrite this because I very much messed this up. So this would be secant squared of 3 pi over 4, and then minus cosecant squared of 7 pi over 6. So now what we're going to do is I'm going to draw my snowflakes. I'll do them over on the side here. So 1, 2, 3, 4, 1, 2, 3, 4. And then over 6 be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, starting at 0. So for 3 pi, I have to start counting in quadrant 1. So 1, 2, 3. That puts me in quadrant 2 with a 45-degree angle, because again, 180 divided by 4 is 45. So this would be negative 1, 1 root 2. Secant is the inverse of cosine, so that would be hypotenuse over adjacent. Now going to cosecant squared of 7 pi over 6. So starting at 0, you're going to start counting in quadrant 1 because this is a positive 7. So 1, 2, 3, 4, 5, 6, and 7 puts me in quadrant 3. And 180 divided by 6 is 30. So it's a 30-degree triangle, negative root 3, negative 1, and 2. And cosecant is the inverse of sine. So now that we have our triangles, now I'm going to go hypotenuse over adjacent would be root 2 over negative 1. So negative root 2. And I have to square that. Then minus hypotenuse over opposite, which is going to be negative 2. And I'd have to square that as well. So I'd have root 2 squared would just be 2. 2 squared would actually be 4, which means that my answer would be negative 2. And that should conclude your questions on lesson 50. I hope you have a great day. Bye.